I wanted to cover this lesson with you today. This is still in section 4.3, but I want to talk about multiplying two matrices together. In our previous lesson in section 4.3, we talked about scalar multiplication. That's where we take a single number and we multiply it times the matrix. As you can see here, we had this in our notes from the other day. So scalar multiplication is really pretty easy. It's really like the distributive property in a way, just taking a number, in this case 4, and multiplying times all of the elements inside the matrix. And that helps us solve some problems like you had on the quiz, equations like this, where you're using scalar multiplication times 2 times this matrix. Well, and today we're calling this part 2. I want to show you how you can multiply two matrices together if it's possible. And in today's lesson, I want you to understand whether or not the multiplication of two matrices is possible. And if it is, then how does that process work? So let's just get started with an example. Here I have this blue matrix, this 2 by 2. Being multiplied times this red matrix, also a 2 by 2. So the first thing that you need to remember when you are attempting to multiply two matrices together, and I've got this here for you on this slide, you should check out the dimensions of each matrix. And what do I mean by that? Well, for this blue matrix, I just wrote the dimensions in blue. You can see here I just wrote 2 by 2. Remember, that means 2 rows and 2 columns. The red matrix is also a 2 by 2, 2 rows by 2 columns. So here's how you'll know whether or not matrix multiplication, the multiplication of two matrices, is possible. You notice how I've got my green line that is pointing to these numbers on the inside. So if you were to show the dimensions of each matrix, focus on the inside numbers, and if they match, and in this case they do, then you know multiplication of those two matrices is possible. Okay, and then if it's possible, you have further information regarding these outside numbers, and I've given this to you also. The outside numbers will tell you the dimensions of the product matrix. Remember, product is just another way of saying the answer to multiplication. So two things can be told by the dimensions. Can be done because the numbers match on the inside, and the outside numbers will give you the dimensions of the product matrix. So I know when I'm finished, my product should be also a 2 by 2 matrix. And I would recommend, especially while this is new to you, most of you have never gone through this multiplication process before. When you've identified that it can be done and you know what the product matrix dimensions should be, just make yourself, like I've done here, a blank. You see how we got 4 blanks representing a 2 by 2 matrix, and that really helps give you some direction as to what your final answer should look like. And we'll work now on finding out what these 4 numbers are. We'll fill in these 4 blanks, and that will be the answer to this particular problem. So on my next slide, I'm going to walk you through the actual multiplication process. So this is the same problem as before, those same two matrices. And how do we get this product matrix? Well, multiplication of two matrices involves multiplying a row times a column. You always do row of the left matrix times column of the right matrix. And by the way, I meant to mention this earlier, matrix multiplication is not commutative. Now, maybe you don't remember what that term means, but the commutative property says that with real numbers, if I multiply 4 times 3 together, that's the same thing as multiplying 3 times 4. I can change the order of these numbers, but for multiplication involving real numbers, it doesn't matter. It's going to be 12 either way. Well, that property, that commutative property, is not true when it comes to matrices. So for example, if I were to take these matrices and switch them, I'm going to get a completely different answer. So matrix multiplication is not commutative. You cannot change these matrices around. You must take them as they are given in your problem and see, first of all, can they be multiplied in that way? And then if they can, here's how you'll get your product. So I've done some color coding just so you can kind of follow this process maybe a little easier. And once you've done a few of these, it's really not too bad. So remember, here we are trying to fill in the blanks of our product matrix, and I'm going to work on this blank first. This is considered row 1, column 1 of the answer. So to get this answer, row 1, column 1, I'm going to use row 1 times column 1. Remember, it's always row times column. So I've just color-coded these for you, focusing on this row from the left matrix times this column. Just match up the red numbers together, -3 times -1. Then you will always add, always. Now let's do the blue. So 3 times 3. So it works like this. The first numbers, the first number from the row times the first number of the column, plus the second number of the row times the second number of the column. So row times column, put those together. This is going to be +3 plus 9, and that gives me 12. So this number, row 1, column 1 of my answer will be the number 12. Okay, let's just move over to the right, and we'll work on the number that is in row 1, column 2. So in my answer, this represents row 1, column 2. So let's use row 1 times column 2. And once again, just match them up by colors, the way I have it here. The first number times the first number. So that's -3 times 0. Plus, now do the second times the second. And that's 3 times -4. Okay, 0 plus -12, of course, is -12. All right, let's work on this answer, part of our answer, which would be row 2, column 1. So just think of it this way. If you're trying to find the number that goes in row 2, column 1, then you're going to use row 2 times column 1. And it's the first times the first, or the reds, 5 times -1, plus, and now do the seconds, or the blues, 0 times 3. I was going to change colors there, but just to match these up, but I think you get it. 0 times 3. So 5 times -1, that's -5, plus 0 is -5. Okay, now this number in my answer represents row 2, column 2. So I'm going to use row 2, column 2. First with first, red with red, plus, and then second of the row times second of the column, or the blues, together. Well, this is just 0 plus 0, which is 0. And that is known as my product matrix, the answer to this multiplication problem. Okay, let's try another one. Well, once again, I'm asked to multiply these two matrices together. I can't change them around. I've got to work with them just as they're given. So you notice I wrote the dimensions of this left matrix. It's a 2-row by 3 column, or 2 by 3. This right matrix is a 3 by 2, 3 rows with 2 columns. So I observe, and those numbers on the inside of the dimensions, they do match each other. So multiplication is possible. And my outside numbers, in this case, these outside 2's, tell me that my answer is going to be a 2 by 2. So I just went ahead and set up a blank 2 by 2 matrix. And we're going to work on filling in, finding out what these 4 numbers are. Okay, so just remember, this element in the product is row 1, column 1. So we're going to use row 1 times column 1. And I've got these color-coded for you. So first times first plus second times second plus third times third, where you can see green, red, and blue. All right, so 4 times 4 plus 3 times 8 plus 2 times 10. Okay, and now we just simplify all this out. This is 16 plus 24 plus 20. 16 plus 24 is 40. 40 plus 20 is 60. Okay, now let's work on row 1, column 2. To get this row 1, column 2, I'm going to have to use row 1 from the left matrix times column 2 on the right. So just match them up. Green times green, 4 times 7 plus 3 times 6 plus 2 times 5. All right, 28 plus 18 plus 10. 28 plus 18 is 46 plus 10 is 56. Okay, this is row 2, column 1. So we're going to use row 2 times column 1. All right, green with green, 0 times 4 plus 1 times 8, the reds, plus negative 7 times 10. 0 plus 8 plus negative 70 is negative 62. And so for row 2, column 2, I'm going to use row 2 times column 2. First and first, 0 times 7 plus second with second, 1 times 6 plus third with third, negative 7 times 5. 0 plus 6 plus negative 35 is negative 29. Okay, and that is what we call our product matrix. That would be the answer. Okay, let's just work through this one just for practice sake. Obviously, if these are both 2 by 2's, we've already done one like this before. So they can be done because the inside numbers match and the outside numbers will be the dimensions of the product. So I'm going to have a 2 by 2 product matrix. Okay, so for row 1, column 1, I'm going to use row 1 times column 1. 1 times 5 plus 3 times 3. 5 plus 9 is 14. Row 1, column 2. So use row 1, column 2. 1 times negative 2 plus 3 times 6. Negative 2 plus 18 is 16. All right, row 2, column 1. Row 2, column 1. Negative 2 times 5 plus 4 times 3. Negative 10 plus 12 is 2. And for row 2, column 2, use row 2, column 2. Negative 2 times negative 2 plus 4 times 6. This is 4 plus 24, and that's 28. And that's your answer for number 3. Number 4, another example. Just to be safe, you should check out the dimensions. My blue matrix is a 2 by 3, 2 rows, 3 columns. The red matrix is a 3 by 1, 3 rows, 1 column. Notice three numbers representing rows with just a single column. But the inside numbers match. Notice the 3's match each other. So when I'm done, I'm going to have a matrix that is a 2 by 1. Those outside numbers indicate the dimensions of the product matrix. So this is 2 rows, 1 column. So once again, I would strongly recommend you setting up your blank matrix so you know exactly what your answer is supposed to look like. Okay, so let's work on. This is row 1, column 1 of the answer. So let's use row 1, column 1. Of course, there's only 1 column. It's got to be column 1. So let's match them up. 2 times 2 plus, now choose the seconds of each, 3 times 9 plus, and now -1 times 4. Okay, 4 plus 27 plus -4 is 27. Okay, now let's work on row 2, column 1. So row 2 from the left matrix times column 1 of the right, and just match them up. First ones, 0 times 2, plus, now do the second of each, -5 times 9, and now do the third ones, 4 times 4. So this is 0 plus -45 plus 16. Okay, so this is -45 plus 16 is -29, and that is the answer to number 4. All right, let's take a look at number 5. If you compare the dimensions, the red matrix is a 2 by 3, 2 rows, 3 columns. The blue matrix is a 1 by 3, 1 row with 3 columns. Okay, well, if you notice, the inside numbers do not match. So this is pretty easy. If this happens, you're just going to say that this is not possible. And you just move on to the next problem. If these inside numbers do not match, when you write down the dimensions, you cannot do multiplication of 2 matrices. Okay, let's try this one. This is 1 row with 2 columns, or 1 by 2. This is 2 rows with 1 column, 2 by 1. The inside numbers match each other, so we can multiply these together. And the outside numbers tell us that we're going to have a 1 by 1 matrix. That's just like saying it's a matrix that consists of just one single number. Okay, so you can think of this as row 1, column 1. So all we're going to do is multiply row 1 times column 1. -2 times 2 plus 4 times -4. -4 plus -16 is -20. And that is my answer for number 6. All right, let's keep on moving.